Assalamualaikum and good morning. So today we will learn chapter 6, angles and tangents of circles. Okay, welcome to the class. Okay, so for today's lessons, make and verify conjectures about the relationship of angle between tangent and chord with angle in the alternate segment which is subtended by chord. Okay, so first, we want to see the relationship of angle between tangent and chord with angle in alternate segment which is subtended by chord. Okay, so based on this diagram, okay, we have PQR and SQT, which is the line of PQR is tangent to the circle SQT. Okay. So this one is tangent. This line is tangent to circle. Okay. And as you can see that, okay, this one is the minor segment, and this one is okay, and the shaded one here is the major segment. Okay, and as you can see that the line ST here, actually this one is chord. Okay, this one is chord. The line of QT also chord. Okay, and the line of SQ also chord. Okay, so based on this one is more to segment, and you can see the diagram 1B here. Okay, if you can see here, this one is the OS is the radius, okay, and the OQ also radius. And we know that if radius and the tangent to the circle, okay, the angle here will be 90 degree. Okay, this one will be 90 degree. Okay, so this line, as you can see, this one also implies the one that we learned before, which is this one is the rocket. Okay, the shape of the rocket here, and we know that the angle at the center is twice. Okay, is twice from the angle at the circumference. Okay. Okay, now we want to see what is the relationship between the tangents and the chord. Okay. Okay, so based on the statement in the diagram 1E and 1B, we can conclude that, okay, if you have chord, okay, if you have chord here, and as you can see that all vertices here is lie on the circumference, so you have 3, so 1, 2, 3, okay, which is SQT, and there is a line which is tangent to the circle. Okay, from here we can conclude that angle X is equals to angle Y. Okay, exterior angle is actually equals to interior angle. Okay, interior angle of a triangle here, and this one is theta. Theta is equals to beta. Okay, because the angles between the chord and the tangents are equal to the angles at the alternate segment subtended by the chord. Okay, so we just want to learn this property. So X is equals to Y here. Okay, must be opposite here. Okay, and another one here is the theta is equals to beta. Okay, so now we move on to the question. Okay, state the pair of angles with the same value in following circle. Okay, so alternate, okay, which is opposite to the angle, so which is X here. Okay, we see that X here is actually equals to A inside the triangle here. Okay, so angle X is equals to angle A. Okay, and the other one here is Y. Okay, Y here is equals to angle Z. Okay, so next one here. Okay, this one you see that we have two triangles. Okay, so the first one. Okay, and the two triangles here. Okay, all vertices are lie on the circumference. Okay, and we also have tangent, line of tangent to circle. Okay, the first triangle here. Okay, as you can see, the angle X is outside. Okay, here is the angle X. So axis is actually, the angle axis is actually same as angle B inside here. So angle X is equals to angle B. Okay, and another one here, we have this angle. We have this triangle. Okay, the second triangle here. Okay, so we see that angle outside from the triangle, which is exterior here. Okay, alternate with angle at A. Okay, so you must remember, you must be alternate to each other. Okay, so angle Y is equals to angle A. Okay, so we move on to the next example. Okay, the diagram shows a circle where AB is a tangent to the circle. Given angle BAC, okay, BAC is equals to 42 degrees. Calculate the value of X. Okay, so now you need to find what is the value of X here. Okay, and we know that AB is tangent to the circle. Okay, AB is tangent to the circle. Okay. Okay, so by using the one that we learned, okay, the relationship. Okay, so first you see a triangle here, and as you can see, the vertices is lie on the circumference. Okay, so here we have A, C, and D. Okay, so you can see that this angle, okay, is actually outside, okay, which is exterior from the triangle. Okay, and we know that using the relationship between the chords and the tangent, so actually 42 is equals to angle at D. Okay, so here D is 42 degree. Okay, so from here, as you can see, okay, these two lines here, okay, is same length, which is, as you can see, that this triangle is isosceles triangle. Okay, so this one is isosceles triangle. So we want to find what is the angle at A and C. Okay, angle at A and C here. Okay, so we want to find the angle at A and C. So 180 minus 42. Okay, so you will get 138. Okay, so from 138, okay, 138, so divide by 2. So 138, okay, divide by 2, so you will get 69 degree. Okay, so angle at A and C is actually 69 degree. Okay, so this one is 69. And this one also 69. Okay, so now the question asks you to find what is the value of X here. So what is the value of X here? So you can see we have a big triangle one, so which is A, B, and D here. So it's a one big triangle. Okay, so we know that 42 here, and then we can plus this angle here, and then we can find x. Okay, so x plus 42 degree plus 69 plus 42 is equals to 180 degree. Okay, so now we want to plus. So all together here is 153. Okay, 153 is equals to 180. So x equals to 180 minus 153. Okay, so the answer is 27. So x here is 27 degree. Okay. Okay, now we move on to the next example. Okay, the diagram shows a circle with center O. PQ is a tangent to the circle. Okay, same. PQ is tangent to the circle. Okay, and we see that this triangle here, okay, which is all side here is a chord. And this triangle here is, okay, the vertices here is lie on the circumference. Okay, and given that PSR is equals to 38 degree, calculate the value of x. Okay, so now calculate the value of x. So actually x is equals to, okay, based on the relationship that we learned, okay, actually x, this one, okay, alternate to angle at R. Okay, so this one is actually also same with x here. Okay, so we need to find what is angle at R. Okay, as you can see, this triangle is actually we must use the one that we learned before, which is, as you can see, RS here is the diameter. Okay, when we have a triangle, which is we have a diameter here, okay, the angle which is opposite to the diameter here, actually this one is 90 degree. Okay, so now we want to find angle at R. Okay, so which is x, which is same with x, so x is equals to 180 minus 90 minus 38 degree. Okay, so you will get the answer here is 52 degree. Okay, so this is how you solve question by using a different properties that you have learned before. Okay, that's all for today. We see you in the next class. Thank you.